Section 2.1 talks about frequency distribution for organizing and summarizing data. A bar graph. That's what we start with. Bar graphs, those you would see in a lot of newspapers, you would see on commercials on TV, certain measuring devices. An example, we ask a sample of people who they believe will win the Oscar for Best Picture. 20 of them said A Star is Born, 15 Black Panther, and 2 Crazy Rich Asians. Is this a qualitative or quantitative data? You're asking a sample of people, who do you believe will win the Oscar? So that's definitely a quality. What percent of the people said A Star is Born? Well, that's 20 divided by, what is that? If I take 20 at 15 plus 2, that would be 37. So this would be 46%. It says, what percent of people said Black Panther or Crazy Rich Asians? Well, that would be over 37. That would be the 15 or the 2. That would be 17 out of 37, which happens to be, I made a mistake. This is actually 54%. Okay, well, now it's asking, is this an example of descriptive statistics or inferential statistics? Well, this is descriptive. And they're also asking, our above sample consists of Marina Del Rey residents. So these are the residents of Marina Del Rey. Let our population be Marina Del Rey residents, and there are 10,000 residents in Medina Del Rey. How many would you expect to say A Star is Born will win the Oscar for Best Picture? Well, there are 10,000 multiplied by 54%. We would say roughly 5,405 Marina Del Rey residents think A Star is Born will win Best Picture. Alright, couple of definitions. A frequency distribution lists all the categories along with their corresponding frequencies. Note, a frequency table shows how a data is distributed among several classes. We're going to define a few things. It seems like a lot. We're going to do an example and clarify that. Standard terms of a frequency distribution. There is a lower class limit. Those are the smaller numbers that belong to different classes. As I do an example, I'll point out what that means. There is upper class limits. Those are the larger numbers that can belong to different classes. Now, class boundaries are a bit messy. Anytime you want to find class boundaries, add 0.5 to each end. I'll show you what that means. So they describe how to do that. Let's, find the size of the gap between the upper and the lower class. Take half of that amount, subtract it from the lower class limit, add it to the upper class. Add the lower class limit from one class to the upper class limit. Yeah, and divide it by 2. Okay. Midpoint is simple, just like algebra. If you want to find the midpoint, which is the average, add the 2 points, divide it by 2. There it is. That's how you find the class midpoint. And a class width is the difference between two consecutive lower or upper class limits. Again, I'll point all of this once we start with an example. Let's read this. Here it says, steps to creating the class. The classes for frequency distribution. 1. Decide on the number of classes. Now that depends. Normally we choose anywhere between 6 and 8, depending on how big or spread the data is. Find the class width using, and this is the class width. Take the maximum value minus the minimum value divided by the number that you chose. Always round up to make sure that you include all the values. You cannot have a description of a sample data set and leave one measurement out. Start with the smallest value, that's the lower class limit. Add the class width and you will get the upper, and repeat. Continue until you have the correct number of classes. Ensure that all data values are included in the classes. The following data set represents the age of US at which each US president was first inaugurated. So we have a list of numbers: 57, 61, 57, 57, 58. In the 50s we have quite few. 60, 54, all the way. Use the data to complete a frequency distribution using 7 classes. So we want 7 classes. We need to figure out the class width. That would be the largest minus the smallest. The largest in this case seems to be 78. The smallest, 50, 60, 49 so far, 49, 48 so far, 46, wow, 46, 46, 46, 46, 42, it seems to be 42. So take the largest minus the smallest, which is the length of the line, let's say, divided by 7. That would be 36 divided by 7. That would be 5.14. We always round up, so we use 6. Now what? Now I'm going to start with the lowest, which is a 42, and I'm going to add 6 to get, if you remember what it says, start with the minimum data value as a lower class limit, add the class width to get the next lower class limit. So be careful, when you add 6, you're going to get 48. Add another 6, that's 54. Add another 6, that is 60. Add another 6, that is 66. Another 6, 72. And another 6, 78. So that is 1, 2, 3, 4, 5, 6, 7. Matches. Oops. Oh no, I'm sorry. 7 matches. Okay, now if I go from 42, well, obviously that's going to have to end at 47. This is going to end at 53. This is going to end at 59, 65, 71, 77. So I notice I'm adding 6 every time. And if I add 6 to this, that would be 83. So that's how it works. Now I need the frequency. I need to figure out how many in each of those we have. So let's see how that works. Actually, this. So the frequency, you will do the count. You will figure out between 42 and 47, for example. Let me do the first one. So 42, 47, that's 1. I'm sorry, that's not 1. That doesn't count. That is 1. That's 2. That's 3. That's 4. That's 5. And let me make sure. So if you clear everything and do a, I erased it. That's okay. So that is 1, 2, 3, 4. Did I lose anything? Let me see. 49 doesn't count. 50, no, 48 doesn't count. 46. That's all I see. 1, 2, 3, 4. I see 5 of those. Actually, 6 of those. 1, 2, 3, 4, 5. I see 6 of those. And between 48 and 53, there'll be 11. Between 54 and 59, there'll be 17. Between 60 and 65, there's an 8. Between 66 and 71, there's a 3. 72 and 77, there are none. And there's 1 there. If I count them, that turns out to be a 46. Now, what are the lower class limits? Again, keep in mind, lower class limits are right there. That is 42, 48, 54, 60, 66, 72, and 78. What would be the upper class limits? That's, oops. That would be those. So that would be 47, 53, 59, 65, 71, 77, and 83. Now, class boundaries, those were a bit off. The easiest way to say those is for you to really take a class, add 0.5, add 0.5. That's the best way to look at it. So if I take the very first piece, if I take 47 plus 48 divided by 2, that would give me, actually, if first take 48 minus 47 divided by 2. That will be 1/2, which is a 0.5. So that tells you what to do. You're going to expand this by 0.5 up and this by 0.5 down. If I am at 42 and I run, so let me do the first one. If I expand on this by 0.5 and expand on this by 0. If I am at 42 and I move to the left, that's 41.5. If I am at 47 and I shifted to the right, isn't that 47.5? Now notice, when I shift this down, that becomes 47.5 as well. So they'll match. Then I'll get 53.5, then I'll get 59.5, then I'll get 65.5, 71.5, and 77.5. You'll notice if you subtract any of those, you'll get 6, which is the class midpoint. Class midpoint. Class midpoint is simple. Take those and divide them by 2. So add them and divide them by 2. If I take 42 plus 47 divided by 2, that would be 44.5. If you do it for the next, that would be 50. That would be 50.5. Again, if you add 6, you'll get all of those. 56.5, 62.5, 68.5, 74.5, and 80.5. If you want to find the class of it, take any lower end, any, and subtract it from the previous. So if I take 48 minus 42, that would be 6. Alright, next one up, we would like to talk about relative frequency. Relative frequency is nothing more than percent. That's what relative frequency is. The relative frequency distribution includes the same class limits as a frequency distribution, basically what we just did. But relative frequencies are used instead of actual frequencies or count. So they're asking, tell the age, use the previous data to complete the relative frequency distribution and relative distribution, relative frequency, which is percentage. Relative frequency can also be re-expressed as a percent frequency. I hope you know that, that's the same thing. So if I go back and I copy down, the ages were 42 through 47, then we had 48 through 53, then 54 through 59, 60 through 65, 66 through 71, 72 through 77, and 78 through 83. Well, here we had 6 out of 46. That is roughly 13.0%. Here we had 11 out of 46. You plug that in the calculator. That turns out to be roughly 23.9%. Here we had 17 out of 46. That is roughly 37.0%. Then in this category we had 8 out of 46. That is roughly 17.4%. And then here we had 3 out of 46. And that turns out to be roughly 6.5%. And here we had none, so that's 0%. And here we had 1 out of 46, which is roughly 2.2%. If I add those percentages, they should add up to 100. Sometimes you're slightly off depending whether you round it up or down. That is no big deal. There's also a cumulative. Cumulative means you add, you sum them up. Use the data to complete the given frequency. Under the lower class was 48. The next one was 54. Then we had 60. Then 66. 72. 78. And 84. We had 6. And then in the next one we had 11. So if you add cumulative, you add 11 to 6, that is 17. And in the next one we had 17. So if you add 17, that would be 34. The next one up, you had 8. So if you add 8, that would be 42. Then 3, that would be 45. Then we had 0, that's still 45. And at the end you had 1. So that would be a 46. Cumulative, you add, eventually you're going to get to 46 every single